Okay, now that you have the disk connected to the controller, it's time to do the actual calibration. The process is very simple actually. You just have to show the disk with the controller attached to the camera from a bunch of different positions throughout your VR space, and also from a bunch of different orientations, which is important to calculate the position of the disk with respect to the controller. So you see when I show the disk to the camera, you get this red representation. That's the disk extractor. It shows what disk it sees and draws it in red, so you can see how well it aligns with the physical white disk. This is one way to keep track of what's actually going on. So the idea is you just hold again the controller out in different positions orientations. When you have a tie point that you want, you press the button. While you're pressing the button, you try to hold your hand as still as possible, because right now there's no accounting for time offset between tracking data and the camera data. And the first 5 tie points you won't see a change, but then afterwards you're going to see the calibration update in real time on the screen. So I'm collecting the first tie point from the middle of my VR space, pressing the button. So now you see there's a line, a red point at the top, that's the center of the disk, and then a cyan point at the bottom, that's the current tracker, and there's a line between them because they're currently not aligned. Now I get another one, and you notice I twist the disk inward to get a different orientation. As a reminder, that is very important to calculate the center of the disk in tracker space. Another one from up here, and then one from down here, let's say. Okay, and then one more. Okay, now you notice a change. So the calibration has now been calculated. Now you see the cyan cross there, how it's following around the disk and how it's very close already to the center of the disk. And ideally it's exactly in the center of the physical disk. That shows that you have a good calibration. You can also follow along in the configuration dialog here. If you go to, I should mention, if you go to disk extractor and your camera has for some reason a hard time finding the disk, you can change the parameters for the disk extractor to make it easier, but the default should work just fine. Under disk center, it shows us the position of the disk center in controller space based on the current estimate, and it's in meters. And then under extrinsic calibration, you can see the current alignment residual, which right now is 2.6 millimeters, which is very good actually. So we want to aim for that. But we only have a very few tie points, so what we want to do is collect a whole bunch more. So you just want to cover your space, and you see how every time I press the button, the image might jump a little bit. That is when the system figures out a better way of aligning tracker space and camera space. It will update the display to reflect that. And that's pretty much it. You don't have to collect a fixed number of points. You just want to make sure you can actually interactively just move the disk through the space, and then you see if it follows well. You don't have to collect more tie points, but if there's any discrepancy anywhere, well, maybe not exactly at the edges of the camera's point of view, because there's going to be some nonlinear distortion. But if you see that you don't like the calibration anywhere, just collect another few tie points in that area, and that will usually clean it up. So we are at this point done. I'm just collecting more points because it's kind of fun. What happened just there was that the tracker lost tracking for a bit, so it's where the crosshair swam a bit. And you notice that here these tie points, they're not perfectly aligned. There's a little line between them, but that doesn't really matter. The system is set up. It uses ransack to ignore a small number of outliers like that, which might be caused by temporary tracking. So I was shadowing the tracking base station with my body in that particular location. So that were not good tie points, but again, ransack will do a decent job of ignoring them. So we are done at this point. Once you have enough tie points and you're happy with your calibration, and right now we have a RMS of 3.7 millimeters, which is pretty good. That's about the limit that the Kinect can provide us due to its linearity or non-linearity. Then you can click on the Save Alignment button, which will take a few seconds. It will run a much more aggressive nonlinear optimization, which might reduce the error even further. In this case by 1/10 of a millimeter, so it wasn't really worth it. But when you press the button, it then saves the final calibration directly into the calibration directory for that camera, so that the next time you run Kinect Viewer, the tracking spaces will automatically be aligned. So that's it. And we can shut this down.